practice with a way to connect. A way to tap into the collective wisdom of the crowd. A way to co-create with the global RISE community. Scale your vision to the global market through RISE. This is an invitation to the innovators of the world.
It's already recording, so.
Connect. Co-create.
Well, not perfect, but it's better than nothing. It's recording.
To RISE.
You want to sit down?
No, I need to see the phone. So.
Good afternoon, everyone. My name is Conway, and I'm the Ecosystem Manager here at Barclays RISE. We're a FinTech Innovation Hub. We have sites in London, New York, Manchester, Vilnius, Mumbai, Tel Aviv, and Cape Town. We will be opening our next site in San Francisco next year. We are obviously working alongside entrepreneurs to find solutions for financial services. We've got three main activities from here. We've got the Barclays Accelerator, which is run by Techstars, the co-working space, which is how we know Jacques. He's a member here at RISE. And then this is our event space where we hold a number of meetups. We have the Ethereum meetup here as well on a regular basis. And we also have thought leadership seminars, hackathons, all sorts of things. So if you are interested in our other events, make sure you sign up for the newsletter and on our Facebook page as well. This is Nicole, my colleague. She runs all the memberships and takes care of everybody here. So if anyone wants to know more about how you become a RISE member, just chat to her. But it's a great pleasure to have Jacques and all of you here this evening. This is a very big theme for us in FinTech, so we're keen to nurture this kind of thinking and create a space where we can build this kind of knowledge together. So enjoy your evening and come and find us if you have any questions.
Thanks, Camila. Appreciate it. Well. Okay, so the beautiful plan. So just quickly set up here. Okay, excellent. First of all, thank you very much for coming through. This is our kind of fourth MIIA Meetup, and we've kind of done this now. We started actually I've got a slide actually to show you the progress and how things evolved over the last few months. It's been absolutely amazing to see the growth, the interest in data science, in machine intelligence, its applications. And with machine intelligence Institute of Africa, we set out a very lofty goal in terms of helping to transform Africa through machine intelligence. And when we say machine intelligence, it actually refers to artificial intelligence, data science, all of that. And what you also see here is focus on research and applications. And I think there's probably more applications, but I've got personally also a big interest in research and actually advancing the state of the art in machine intelligence. And when you go to the MIIA website, you will see specific research topics as well, which is interesting. And I know there's a few guys here that's really interested, and we had some really interesting talks. So maybe in the future we can actually have a session on that. We can talk about that as well. But I think most of the interest is in applications, and what I plan to do, just quickly in terms of the agenda, this is the agenda as I communicated in the email and also on various social platforms. what I would like to do is just a quick short presentation on just MIIA developments so everybody sees exactly what's going on. I also, a few people also, a number of people participated in this MIIA survey. And what we wanted to do there, remember this thing is for the community, it's for us, and it's how we want to utilize this. So I've just asked about the format, what people would like to see, how they would like to participate, etc. So that's been captured. I just want to quickly share. This is what the community, or at least a representation of the community is saying. Then we've got Paul Saunders here. He's going to, we found it, well, I found it with him. He's getting up the Data Science Academy, so we'll be talking about that. You'll be talking about that for a few minutes. We've got a few slides on that, and very excited about that. There's quite a bit of pull and interest in that. Welcome. And then thirdly, I want to quickly have to show you a demo of Bennit.AI, which is an intelligent production system for manufacturing. Then we're going into, and what I like about this community is there's so many interesting things happening, and people, we want to provide this kind of a platform where people can share use cases and so forth. So one of them is Alex Conway. By the way, is Alex not here yet? Do you know someone else?
I'll send him a WhatsApp.
No, he's coming. I was with him yesterday. I did a presentation at Launch Lab, and he was also there. So anyway, we're going to move that one to down as well, because we're going to finish the presentations first, and then we're going to do the demos. Helge is going to talk about causality. There he is. So really interested in that talk. And then Charles Copley, he's currently at Zoona, and he's going to talk about social network analysis. And here he is. Which is a very interesting topic, and a lot of interest from corporates even. I know Barclays is very interested, and various companies are very interested in this, so looking forward to that. And you've got this experiment, you're probably going to talk about this in terms of social network analysis with the MIIA community.
Sure.
Yeah. And then finally, Thuso. Is Thuso
in traffic? No,
is it? It's in traffic. So
maybe you can just point to that link over there.
Well, that's right.
Go into that link.
Well, that's right. So maybe, do you want to?
Sure.
Yeah.
I'm just going to quickly do this now so that we don't everyone has time.
Okay.
Because you can probably see it. I'm going to break even.
Yeah.
On this link, you will find a list of names which were taken from the MIIA Meetup group. So first I should just say you don't have to fill this in. That's very important for everyone to understand. It's a list of names from the MIIA Meetup group, and you can select your name from that. And then another list of names also from the MIIA Meetup group where you can select the people that you know. And the idea is that we should be able to create a network of people amongst this group. Not real time, but I can try and send that out to everybody later. Okay, can everybody see this? I don't know.
So then what I will do is, I'll just lift it there. Okay. For a second. So there it is. So you want to go there. While we're still waiting for some of the speakers, I know there's a time limit here as well. Okay, so everybody's got it?
If you need to know on the list. It should be a checkbox to complete. Your name and
Okay, so everybody all right? Got it? So I'm just going to move it back. Okay, so let's fire away. And we can keep this also very interactive. So there's going to be presentations, but we want to allow time for talks as well. So here's the guys. Number boost. So they have arrived. That's right. Okay, so just to quickly the real great thing is this community is great. Is already more than 250 members and followers. And really the exciting thing is, just with these partners as well, I think this is exactly what we want to achieve, is to see how we can collaborate and what are the synergies between the various different parties or organizations here, and really try to piggyback on that. Now, some of the interesting things here, so I was yesterday at the Launch Lab, Stellenbosch University as well, and we've got a whole project. I've got some slides on that I would like to share for 2017, planned out different streams, which is very, very exciting. ACE-DS is actually Africa Center of Excellence for Data Science in Kigali, Rwanda, and I had the guy that founded that for actually, he was here in South Africa last week, so we had him for a barbecue, proper bride at my place as well. And they are very keen to help and collaborate. They are funded by the World Bank as well, so I expect some interesting things from that perspective as well. Okay, so to just give you a, so this is kind of the story of the last few months. We've launched the MIIA website in March, April, May, and then our first meetup was here in Jumo. Really fantastic event. Then we went to Silicon Cape, and then after that there was collaboration obviously with RISE, and a lot of these things in blue is the thought leader sessions where MIIA was represented that Camilla referred to earlier on. And what you can see was quite interesting. In the fintech space, there's two things that's very important, and they are artificial intelligence or machine intelligence, data science, and everything that goes with that. Also, in that, if you look at that, very important thing is virtual assistants. It's kind of the next tech revolution, and the other thing is blockchain. So we have some thought leaders in here talking about blockchain as well. And the interesting thing is there's also synergies. I don't know if you've heard about decentralized autonomous organizations, and then there's some things written about AI, these decentralized autonomous organizations, where the smart contracts in blockchain is driven by artificial intelligence. So there's some very interesting things potentially going forward. Interesting innovation pretty much happening at the intersection of these disciplines and these technologies. But anyway, from a fintech perspective, the interest is really in insurance, investment, wealth management. How can we utilize these technologies into those areas? I also did a talk at Saunders University focused on education. How can we use smart technology and artificial intelligence specifically to improve education? There's some very exciting initiatives going on. I personally also invested in this Student Hub Online. They've got this ERA online platform. Very excited about that, trying to disrupt the whole educational space effectively. And then we actually had here some sessions with the Western Cape government talking about smart cities, IoT, artificial intelligence, and the future of how do we actually embrace these technologies and what we do. So that was a very, very interesting session as well. And then there was obviously this Rise to the Challenge. There was an event here. It was part of all the orange things was actually open events. So there was our third meetup. This one today is the fourth one. There was yesterday also one at Launch Lab. And we actually plan to have the next MIIA Meetup at Launch Lab in November. So we're still looking at various partners and where to actually have these kind of events. Obviously, city is very important. This is obviously this whole building is the second floor, the third floor, fourth floor is all city. So that's the Cape Innovation Technology Initiative, and very exciting to actually launch the Data Science Academy. So things are moving. It's pretty interesting, exciting. The 2017, we're still thinking about all the, and remember this is a community thing, so we need thought leaders, activity leaders to help participate, and there's already interesting initiatives going on. There's for instance, Charles is this whole social network analysis, he's actually leading that kind of effort, and if there's other people interested in that type of thing, we can make that into a proper project, or multiple projects there as well. So, Data Science Training Courses by Data Science Academy. This is the hardware for your humanity project with Launchpad. We want to have some MIIA meetups in major hubs in South Africa, and also go to other regions in Africa. And then just grow the partnerships, partner activities. And we definitely want to be working on the tertiary institution collaboration as well. Community projects. We obviously need funding. We need to get properly funded because of all of this initiatives. There's a lot of strategic stuff going on. So I'm personally working on some things there, but if there's any people that want to help collaborate on that front, please do so. I know number boost is here as well, and from the survey, yeah, there we go. They specifically, I know, talk about hackathons. We should have hackathons here as well. So we definitely going to look at doing that going forward. Okay, so just want to mention that, and then just very quickly, I'm not going to go into details here, but this is we'll share more of this on the MIIA website as well. But this is currently being discussed, the whole hardware for humanity project. We say we create this Launchpad MIIA Developer Zone. And here, key activities is like workshops, meetups, events, summits, projects, tourism camps, even getting scholars from overseas to help participate along with MIIA and Launchpad community. And really creating these town hotspots in Africa as well. So it's very, so it's going to take quite a bit of effort to get this going, but again, if you've got the right partners, stuff is all possible to make a difference and change. The other stream, just at a high level, the first stream is just entrepreneurship, innovation, future trends, aspects of human potential. What's quite interesting from the MIIA survey was also the fact that a lot of people is actually interested in how can we apply this, how can we use artificial intelligence or data science in business context. What is those applications that we're looking for? So anyway, so that's one theme. The second theme is innovation and artificial intelligence, and we also talk about Internet of Things. And the last slide on this is stream 3, looking at leadership, community, and sustainable development goals, Africa in the future. And then the whole thing around this Launchpad MIIA Developer Zone. So a lot of things planned, so we'll see what materializes. We obviously need to prioritize properly here. But this is just one of the things that we're doing with partners. So, and just quickly on this, I mentioned the survey before we get into the use cases. So this was just some of the results coming back. So the first question was just format of the meetings, and most people actually said they like presentations like we have today with the Q&A type of thing. So, but we've also suggested panel discussions. We can have them. So if anybody interested, create those panel discussions. Or we can also set group interactions with topics discussed with smaller groups, and then you share with the group. So you can have those type of sessions as well. But it sounds like presentations is the most popular one. The ribbons, people said once a month was good. The other thing that came out here was just topics. What should we be talking about, discussing? So I put a range of things here, but it was quite interesting. People want to talk about machine intelligence, artificial data science, business opportunities. How do you apply it? Today's talks would be a lot about that, applications. Then also there was interest in data science applications and tools, and then industry-specific things as well. Research, blockchain, IoT, all of those type of things was kind of popular. And then the last part of that survey was just on Data Science Academy training courses, because we are launching, actually in that email I've mentioned that we are starting this data science. Actually at that time I was just more talking MIIA is going to do this, and then I had discussions with Paul afterwards, and we said, okay, let's do a proper thing here with City in the Western Cape. So it was actually good timing. It was just the feedback here was there's actually a number of people in the MIIA community that's interested in being training instructors or participating in this. We're looking at a paid service model. Also, a lot of people want to attend. So this was quite good to see. And there was a number of people that want to help shape the curriculum because we want to be relevant. If you think about the modern data scientists, there's typically those 4 dimensions where you're looking at maths, statistics, machine learning. But there's also the programming, the Python, the R, database, how to work with big data. Then you've got the whole thing around problem solving and the business understanding of the problem, the hacking. And then fourthly, you've got the visualization, the storytelling, those type of things. So we want to make sure that we shape that according to that, but also what industry needs. Paul will talk more about that. And then fifthly, the community activity leaders participation, so anybody interested to help organize, there's a number of people that definitely want to help. Okay, so I think I'm done with this, so I'm going to move over to Paul. So, actually giving me the can.
Cool. Thanks, Jacques. Good evening, everyone. My name is Paul Saunders. As Jacques mentioned, I've been asked, we are, myself and I are setting up a Data Science Academy, hopefully launching early next year. And Jacques just asked me to spend about 5 minutes giving a bit of background, why we're going to be doing this, why now, how we're going to be doing it, and what we're going to be offering. So, yeah, ready. Okay, so why Data Science Academy? We want to ensure that corporate South Africa governments and startups continue to drive innovation on the African continent. That's essentially what Jacques and myself are about. But there's this huge skills gap now that's existing in the data science field. I'm not sure if you guys realize this, but it's become quite obvious to me over the last year that the whole topic of data science has moved fully into the mainstream now. So where people were just talking about it maybe 2 or 3 years ago, people are actually doing it. Technology's caught up with the hype, and it's really exciting times. But there's great for innovation, and corporates are really getting involved and exciting. But it's put a massive demand on the demand side of labor in this particular scenario. So we chat to corporates, they just don't know where to find people. They're struggling, and the data scientists is a rather unique animal. As Jacques mentioned, they typically have multiple skill sets. They come from a very diverse background. They typically have programming, math and statistical background as well. But then they also have to be adept at business understanding as well, problem solving, and then perhaps one of the most challenging ones is telling a good story and visualizing the results and being able to communicate insights to the senior executives so that they can actually understand and take action. So we feel that the time is now right, and it's a unique place to actually to embark on this journey. Ultimately, we want to offer courses across the whole spectrum. So whether targeted at your C-suite executive who wants to understand business problems and how data science can actually solve that. Maybe they want to hold or challenge their technical team on certain decisions that they've made. So there's that type of angle. Then it's your typical data scientist who maybe has 5 or even 10 years experience that wants to get some deep subject matter expertise in a particular technology or a new technique that's come out or a new tool that's hit the market. And then right at the end of the spectrum, we really want to involve internships. So interns typically straight out of varsity generally have a good theoretical basis, but lack the practical knowledge that companies are expecting. So we want to offer programs around that as well. We want to make the programs very, very practical. That's another characteristic. So we want to actually partner with corporates to understand the problems that they're facing in their industry and actually create courses around those problems so that participants in the course will not only just have a very good theoretical understanding, but they actually at the end of the course solve a real world problem that a company is actually facing. So we want to sort of differentiate on that sort of dimension. I'll discuss a bit more about the course later. In terms of the format, we're still debating. We've already had a few brainstorming sessions with potential trainers as well, so people that are interested in becoming trainers. and we've sort of gathered their insights and their contributions as well. There's everything from a 2-day very high level introductory courses to 5-day deep dive courses into a very maybe a particular technology or tool set or a particular technique that's just that's from new and everybody's talking about, all the way through to 1 to 3 month full-time programs. So just concluding, as I said, early 2017 we're starting. We really want to partner with corporates on this. We want to make the content as practical and relevant to the problems that they are solving. So we want to meet with you and actually sit down and understand your needs and requirements in this regard. As I said before, actually get real life problems that you're facing. Maybe source some data, and we can actually part of the course is actually solving those problems for you. I mentioned there is a financial incentive as well, so we want to, if you sign up, then you'll be getting discounts on the first course. Also, we want to build a community of trainers who are passionate about data science and actually want to deliver the content on a paid-for model. So if you fall into either of these categories, or if you just want to be kept informed of our progress and how we progress over the next couple of 3 months or so, I encourage you to go to datascienceacademy.co.za and give your name and email address, and Jacques and I will reach out to you and we'll take it from there. Or meet me afterwards and we'll have a discussion and see how we take it forward.
Thanks, Paul. Appreciate that. Next on the agenda. Thank you, John. Yeah. For that. This is a screenshot from Amazon.com. Someone trying to buy a backpack. And from here, you can see this one is asking what you want a nice laptop to go with that. What is interesting because if someone is not buying a backpack, they're probably already on the laptop, right? So what the point here is that these items are obviously often bought together. So we first buy that, nice to add it back. And that's issue with a lot of the machine learning we have today. It's all based on correlations. So I'm kind of getting quite interested in this idea of causation. Okay.
Maybe if you just speak up a little bit, because I know we didn't have a...
Try to.
Yeah.
So a bit about myself. It's Helge, Norwegian. I work as a data scientist. Background is from applied mathematics. A company called Relaxis. We're running Technopark, Stellenbosch. What do we normally do? Identify causation. So the typical way to do it is through a controlled experiment. So what you do there is you just take your group of experimental subjects and you divide them into two, and you provide the treatment on one group and not on the other one, and everything else being equal. And then say that there's a statistical significance to these. To a difference that we see in the two groups, and we can then say, okay, this treatment was the cause. But as data scientists, we obviously want to work with the data that we have available. And there's also other reasons why you can't always do experiments like this. It might be unethical to do so. It might be very expensive. So I was getting interested in what can we say about causality based on the data that we already have collected. So I just want to explain this thing called the Simpson's paradox. It's quite interesting. I'll explain it through this experiment, which is an experiment. Sorry, an example
is an example from the area of education, a field where we've done some work. And what we're looking at here is learners that are passing or failing the trick, and you're looking at how absence in class affects whether learners are passing or failing. So you can see in the top right graph, we have absence, higher absence, and then we have the corresponding pass rate. And you see that the high absence is a 61% pass rate, and the low absence is 80%. You're inclined here to draw the conclusion that a low absence is good for the pass rate. It would be a natural thing to do. But if you actually go and look at the numbers, things look very different. So down there we have the same, but all I've done is add another variable, which is whether or not you are studying full-time or part-time. And you can see over here, both in the case where people are studying full-time and part-time, a high absence actually has a higher pass rate, which is from which we would draw the total opposite conclusion of what you would have done up here. But if you do and go and work out the averages and the overall pass rates, you get the same numbers. So this seems quite not intuitive, but it's actually a known phenomenon. And it actually turns out to be quite important in this question of causality. I think I've overdone that.
That's not possible.
This is actually got a good point. So there's this guy saying that there's another study that's found no evidence that cell phones cause cancer. I think they got it backward. You see there, cancer incidences went down, cell phone usage came up. So we would, like I say, just be sure I'm assuming that cancer causes cell phones. So, often the problems that I was working on were typical machine learning problems, so make some sort of prediction and come up with some sort of result, saying, for instance, we can predict who are the learners that are going to fail and who are the learners that are going to pass. And we can give that to the client. No? And then the client will usually use their domain knowledge of what's going on to devise some sort of treatment, or what often happens is that Mr. or Mrs. data scientist will say, okay, these are the most important features, and then the client will go, oh yeah, but we should be focusing on that, and they're focusing to improve the most important predictor, just to find that it has absolutely no effect on what they are trying to do, and they wonder why. So what I was really interested in is, what can we say? I wanted something that we can say, okay, if we actually do an intervention, we actually change this thing, then it's a very high probability that we will actually have the effect that we're looking for. And a lot of what I based the ideas on comes from this book called Causality by DFL, and he talks about something called the causal calculus, which is essentially a framework for reasoning about causality. So, I just want to say something about this first. So, in machine learning, there's typically make a distinction between discriminative and generative models. So, with discriminative models, we are just interested in, you have two classes and we want to say, is it class A or is it class B? And we're just interested in that boundary. So, if you're here, depending on which side of the boundary you're on, you say, okay, this is class A or this is class B. But in generative models, we're not interested in how the data was actually generated. So we build one model for class A and one model for class B, and then what's the inverse question of which class was most likely to have generated this data, and then you make the predictions based on that. So this is not the basic idea of causal calculus. So if you have done any work with probabilistic graphical models or relation networks, you should might be familiar. So in a typical setting, we are asking what is the probability of say x4 given x3. And what is in the causal calculus, we are asking what is the probability of x4 given that we do x3. So the difference there is, in the first case, we are just observing the one variable. And then we're asking what is the probability of the other one. But in the causal calculus, we're asking what happens if we actually go and say switch on, force it to be a certain way, which is, if you can agree with me, that's a different thing than just observing it. Actually actively changing it. So this is an example of the same example we looked at previously. We're looking at learners and their pass fail rate together with absence. So the idea is that absence can have an effect on whether or not the learners fail, but there can also be other things, some other factors that we don't really know about that impact both of those. That means if we improve absence, we make learners attend more classes, not necessarily going to increase the pass rate, even though those are very correlated. Actually, the Simpsons paradox is an example of where you can improve absence. You can even have cases where you improve the absence, the pass rate goes down. Because this hidden factor underlifts the average up. So, the trick is actually stick to this example. We actually go and do the math. So that equation at the bottom there, that's actually the probability of y given due x is the probability of passing, given that you actually do an intervention. It turns out if you do a lot of math, you get to that equation which is actually expressed in terms of basic probabilities. So if you look at what I've also done, I've introduced an extra variable. So I'm saying, okay, if learners are absent, maybe they don't get their homework back. And that is the reason we need another variable is that this variable actually acts like sort of a virtual control. It's kind of like that there was actually an experiment happening here all the time. It's just not intentional, but it was there. So it's there in the data. So, I think the bottom part is the most interesting part. If you look at the probability of passing, given that you have no absence, it is quite high. But the probability of passing, given that you actually do an intervention, is actually a bit lower. So if we would have based on intervention on the bottom probability, impact would be much higher than it actually you would have thought the impact would be much higher than it would have been. Which again is a very important result. In this case, you can also say that doing an intervention will actually increase the pass rate because the probability of passing doing the intervention is higher than the margin of progress. But you can also, again, like in Simpson's paradox, you could actually found that doing an intervention. By intervention, I mean you get someone from high access to low access. You use something to make them a technical problem. You could also have a case where if you did an intervention, it actually will result to a lower cost, even though the correlation tells you that, right? I just want to say something about a lot of these graphs. Actually, for this to work, it's actually quite important that the graphs are correct. So this is just, I just want to say something about how to validate the graphs, just to give you an idea of how that can work. So you have, in this case, you have X, which causes Z, which causes Y. And if you look at the data, there doesn't look to be any. That's actually how this data was generated. So what you would have found in this case was that Y would have been independent of X given set. So if you observe set, you know that Y would have been independent of X. That's how you can validate graphs are valid and you can generate. Something about tools that you want to play with this yourself. GitHub is sort of like Causality. You can see here is calculating do very often. Let's play with this. So just another one. So I think causality is something that's important in AI because people we know that we can do it, but it's something one of the things that we're struggling getting machines to do. I'm not sure if this is the answer, but it's an interesting step in that direction, and it's also a very useful tool to have in your data science toolbox. Being able to just say what the effect of the intervention would be is something very common.
Okay, thanks. Thanks, Thuso. You find this what kind of applications?
Specifically in education.
So this is actually what you
Say.
question, Charles. Have you ever, I don't think it's quite the same thing, but have you ever thought of network meta-analysis? You have a series of treatments which don't directly compare because there's no control group. You can compare them indirectly through common treatments. So I don't think, I'm trying to understand what the data were.
It sounds very similar.
It's fairly similar, so it's often used in medical.
The whole idea is that you don't do an experiment. So
Yeah.
you actually use the data. You
Yeah.
have.
Yeah. Good. Great stuff. So thanks, appreciate it.
And turn it into things and behavior changes that grab our company and other things. Okay. So I guess that'll work. So Zoona is a money transfer company, and we primarily do money transfers using a kind of franchise model. So we'll hire, or Zambian entrepreneurs will come to us and ask us for a business, and we'll sell them a booth and let them use our mobile application, which has all the account stuff set up. And then if you have 2 booths in the country, we can send money from one booth to another one using this transaction. So person A comes up to the booth, hands the guy money. Through the magic of the internet, we can send that money electronically to another guy in another place, and then they hand out the cash. And so, in order for Zoona to kind of work, we have a very hub-spoke model. So we have the main core here in Cape Town, but we're distributed across 3 countries. And so we have our main guys out in the different countries, which we call field agents. And so these are the guys that actually go up and set up the booths. They talk to our agents, help them out with whatever is going on, and kind of figure out what problems they have. And so eventually, the goal of Zoona is to try to get over 1,000 agents out there with 40,000 booths in 10 countries. And in order to have enough field agents out there to actually deal with this, we're going to need to hire a whole bunch of people. So instead, we're going to try to be a bit smart about it and try to use our data to try to target things a little bit better. And in order to do this, we've kind of gone through a massive change. So when I first started Data was a team, and we were kind of all together. And this is the data team right up here. And we kind of, every group had their own little silos. And we'd all kind of, when someone asked us to do something, they would come up to us, we'd work on it, and they'd give them back the answer, and we didn't really care what happened after that. So lately we've been trying to integrate better with the other teams. So we kind of realized that data is not a silo. We're a support function. It's like having a computer or a database that's there for everybody. So we try to integrate ourselves into all the different product teams that are around. And also, with that, we're trying to get people to buy into using data. And so we come up with a whole bunch of tools that we use to interact and do stuff with the other teams in our business. So me and the other predictive analytics guy use Python for most of our work. But we also send all of our messages to the field agents using Salesforce. So every morning they wake up with a list of things to do, and they can get that through their app on Salesforce. And then we generate those reports that they're getting every morning on Salesforce through QlikView and getting all that stuff from Java. And we push all the QlikView data into Salesforce using Python. And then we're able to maintain all of our environments because we can use any kind of computer, and we throw that in a Docker container, so it's just portable and you can put it in. So we got a very nice integrated team and diverse in nature, and also diverse tools that we use to try to get around all the different ways we can interact with people. And so one of the big challenges with creating a data-centric company is having a thing of curiosity. So one thing about data, it's really nice to look at. You can see all these pretty plots, but when you actually dive into it, it's a bit scary because a lot of people have to learn math or statistics or all these other complicated things. And so instead what we decided to do was actually showcase the data. So we have our little dashboard up here, a TV in the background, where you can see all of our little dashboards that we put up. And then every day we'll put some funny quotes up there and stuff like that. So when people walk into our office, they actually, the first thing they'll see as they're walking to the main area is our data dashboards. And so this gives people the familiarity and also gives them comfortable about the data that they want to look at. And we've also tried to design the dashboards and whatever kind of data products that the company needs with the person in mind that we're doing. So we often sit down with the department to try to get them to help us design. So this is an example of one of our dashboards that we created with the ops team. So they wanted to see what the different hourly transaction rates were and all the other kind of metrics and how outlets were kind of standing up there. So we sat down with them. They might have been colorblind too, but it doesn't really matter. We sat down with them, asked them what they wanted, and they kind of went and told us. And so they were able to make this dashboard that is sent out now every day. And it actually has been pretty, it seems like a lot of people are looking at it, which is a good thing. And also, looking at this dashboard, you can also answer questions. So it's not only just there for being pretty. It also asks you, like, well, why are there so many inactive outlets? And they can go and dig into that. So we're trying to build this curiosity by building this dashboard. And so part of this is, we always like to think of things in flywheels. So a flywheel is like a really heavy piece of metal that turns. And once you get the momentum up, you'll kind of spin there forever. And so we have the same kind of concept with using data in our company. So getting data centricity was really difficult. But now that it's going, it'll kind of self-sustain itself with just a little bit of input every once in a while. So we kind of are given data or collect our data for a certain problem. And then we analyze that and come up with insights and give those insights to different departments. And the departments can use their domain knowledge and whatever else is going on around them to actually get knowledge and make decisions off of that. And then they'll come back to us with new questions and things like that. And so then we can evaluate and go get new data from that. And so one example of like using this data wheel is our kind of Salesforce messaging our field agents. So we get our data from our data source. And we, at the center of that, we have our kind of triangle of things that we can affect on our different outlets. So we can control, we can tweak all these kind of levers. So we control the float, the electronic float they have, how much money they have in their bank accounts, how much credit we're giving them, what the risk is on this credit, and how much profit they'll make off of all these services. So we can tweak those. And so we take the data, we analyze it in ClickView, for example, and then we send it to our Python API, which pushes it into Salesforce. And then that has a bunch of workflows and operational decisions that are made in it. And then it's sent out to the field where they carry out actions. And then the field guys have a way to talk to us and give us insights back on what is working, what's not. And then we're able to use that feedback to produce better data products for them. So that's one way we kind of use our data to try to build this flywheel and keep it going. Some other projects that we kind of work on. So with those dashboards and workflows that all the field agents are getting, we want to try to make it as easy for them to find the agents that actually really need us to affect them. So instead of having broad strokes across everything, we're trying to really personalize our different metrics. And that means we're doing a lot of cool things with data science and machine learning to do that. We're also working on credit scoring models to minimize risk and also keep our stockholders happy. A lot of our work is actually looking into the optimal placements of booths. So we work really hard, that's what those two bottom maps are, is actually trying to figure out exactly where the best place to put our booths is on a country level. And then also trying to change the limits so dynamically, so when there is actually more need, we can increase the limits automatically. And then as soon as the lines go away, we can shrink it back. And then a lot of the work we spend working on is actually trying to figure out where the network effects kind of happen in our network. So building those nice corridors between two towns that tend to need a lot of money sent back and forth. So that's kind of the stuff we're doing with data. And then this is one of the dashboards we sent out to our field agents. And so this is a new thing we're trying. So it's a performance review for our agents. So we'll every month we'll send this out. It embeds HTML, so it works on their phone or whatever. And then they go out and talk to their agents and say, hey, you're not doing too well. These are the reasons. And so the field agent and the agent that's working out there, they can both look at this thing and say, oh yeah, I can see I was closed a lot last month. And so it kind of drives conversations rather than just us beating them with the stick trying to get them to work properly. So it's really nice that you can build these things and it's more of a conversational tool than a metric or some other kind of very hard thing to And then some of the stuff we're doing in the data science field, more specifically, is we're trying to work on agent-based modeling. So we have a couple of cities where we have OpenStreetMaps data, and we want to know exactly what streets to put our outlets on. So we kind of send agents automatically through the streets and let them go whatever routes they can, and we find which places are the most dense. And then we say, hey, does this actually meet our actual data that we're getting from the streets? If so, then we'll put an outlet there, and we can kind of simulate our flows and improve it. Another thing is we kind of just had like a machine gun spray effect of where we place our boots. So that's what that green line on the second one is. It's just kind of a random throwing of boots wherever you can. And so with some not even super fancy Monte Carlos, we were able to optimize the best placements of the booths to increase revenue effectiveness. So it's all about just making smart choices and being able to use the data for things that are important. And so in the end, what we're trying to do is help people and make communities thrive. And so this is one of our agents who has actually done really well for herself. She started off with us about maybe 2 or 3 years ago, or 5 years ago, and started up her own business, manages it basically all by herself. And since then, she employs 35 people now. She has over 60 booths. She sent $40 million in transactions across Zambia. Made over $10,000 in commission a year, so it's pretty impressive. And helps 200,000 people send money where they actually need to go. And before we came there, our biggest competition was taxis. So taxis would take your money, drive to the next town, and hand off. And now she can make a business out of it. And I was reading an article the other day, and I was looking at, it was about how to alleviate poverty. And so there's about 6 steps to do it. And I think Zoona does all but 2 of them. And so one of the ways to alleviate poverty is actually giving someone an asset that they can use to produce money. In our case, it's the Zoona booth and the platform we're doing. And then since we have our field agents, they can go out there and train these new guys, entrepreneurs, how to actually run the business. And so they're getting training. And we just started up a new model where we actually give the agents a stipend so they can survive the first couple months when they may not know all the tricks of the trade. Fortunately, you don't do home support for them, but I hope that they're making enough commission that they can pay for that. And we're working on a savings product so we can actually have them save with us too. And then we also give them regular visits, so we have all the data metrics to really try to personalize those. So when they actually need help, we're already on top of the ball to do that. But right now, we're kind of regularly visiting all of our agents. So, yeah. Yeah, that's Zoona in a nutshell. Through a third party, so it's not just us.
And can you just explain how Docker fits in that? Actually, kind of went over pretty quickly. I'm not familiar with.
So Docker is a container software, so it's process isolation. So we can, I can have my crazy version of Linux where I built all my tools on, and then I wrap it inside this Docker container and have it run on Windows or any other version of Linux out there. And so you kind of build this environment with all the tools built into it, and then you just click on it and it'll start up the process and run it and do whatever it needs to do, and then once it's done, it dies and goes away. So it's very, very nifty.
I'm curious, the agent-based modeling, do you have a sense how well that is working?
It's very, very beginning stages. So we just got all the kind of groundwork working, and then we're going to start some staging. So we're trying to figure out the best way to actually measure if our model is working correctly. So whether we need to have someone on the grounds pointing at people and counting them as they walk past, or can we get it actually working? So we're still up in the air with that a little bit.
How much does it cost you to transfer and
so
the distance you transfer into with flat rate?
We have some fee beds, so they're optimized to help our agents make the most commission. Yeah, it's complicated. I don't even know that well.
So you mentioned dynamic variables, changing variables. Why or how would you do something?
So the credit that we give our agents is kind of an overdraft. So when they run out of electronic, they'll dip into it. And so we want to set those limits dynamically, especially during busy times, or if it's raining, then we don't want them to have them because they could go and steal the items. So we're just trying to optimize those so that it's when we actually see that they're getting busy, we can increase the limits and then allow them to do those extra transactions. And then as soon as they pace back, bring it back to what they're normal.
One of the things you said was use data to predict money transfer corridors.
Yeah.
And it kind of links a little bit to your question, is those are domestic corridors that you Or would you be able to use the data that you use through the third parties?
We're also doing stuff on international corridors as well with our partners. We've just started working on that data with Kuru and Western Union.
Okay.
So that data does exist, but that's kind of more in its infancy, I think, because Zambia, the international remittance corridors aren't as big. Malawi is a much bigger remittance corridor. I think that's overtaken our domestic transfer in Malawi.
But we're trying to be clever about gravity models and trying to figure out those internal models.
Any other questions? Cool, thanks.
So I'm Alex. Paul over there and I are co-founders of a startup called Number Boost. We have t-shirts because we're a startup. And we do spatial machine learning. If we have to pick like 3 keywords, those are the buzzwords we're going for. So today, I'm going to talk about a project we've been doing on optimizing mobile clinic locations using spatial data. So please email me if you want to chat or just spam me. So I didn't mention this in the title in case Jacques was like, no, you can't present that. But they're actually circumcision clinics. So, yeah. So the clients, the guys we're doing this for, they're a big NGO funded by the Bill and Melinda Gates Foundation and USAID, and they're trying to reduce HIV transmission in Africa. Now, according to the World Health Organization, medical male circumcision reduces the risk of sexually acquired HIV infection in men by approximately 60%. There's a little link. I think this guy's face kind of says it all for me. And I'm quite immature, so these meetings are like, I don't know if they're doing it on purpose or subliminal, but they keep like making these underhand jokes like, yeah, so it's a cut to the chase, or like, no matter how you slice it, I'll try and keep this minimum, but we'll see how it goes. So mobile circumcision clinics. So as part of the whole situation is basically that these clinics are in buses, and the buses can move around. And so in order to, initially they had guys, grassroots, going to areas and trying to sign people up. And the one lady who runs she's like a deputy at the Department of Health, and she was in some of the meetings, and she's like yeah, she kind of like runs the grassroots guys, and she's like, yeah, the way that we sort of like get people to open up when they're walking and doing this grassroots stuff is they're like, I can smell the foreskin. But she said it was like a lot funnier, but so that was grassroots, and then so one of the things we helped them with, totally unrelated to the core of what we're doing, but just this USSD booking app. So I mean, if you dial that number now, it's reverse billed, so you don't get charged for it. So for free, you just dial this USSD number, and then you enter the name of your area, and then we do some like fuzzy string matching to find, if you do a typo or something, and then we tell you what the appointments are in the next 2 weeks within 20 k's of your area. So we know the location of the clinics, we know the location of your area, we can calculate the distance, and then if that distance is within some band, like less than 10 or 20 k's, then we'll say that you can get that appointment, and then we do this whole SMS thing and so on. But the point is that these clinics can move around, so they're mobile clinics, and we can place them anywhere. So the question is, where do we place the clinics? Because there's some like optimal way of placing these clinics that's going to lead to like maximum number of people going and getting this procedure. And these guys being NGO raising funding, they have targets, so they want to maximize targets, but also it reduces HIV because I just like we're talking about these targets, and they're like, oh, we do 40,000 procedures by the end of the year. And I was just like, how many? Apparently, some doctor did like over 200 in a single day. It's like a sushi chef. Like, there's like a bucket with like 200. Yeah, I don't know. So using spatial data. So the basic idea here is we can convert any address. So this can be the clinic's address or the delivery address to our e-commerce clients or the store location into coordinates. So over here, turning an address into coordinates is geocoding, and then if you plot this address on a map and you also know other things about the map, then you can do like a spatial VLOOKUP, if that makes sense. Because like if I'll explain this more clearly when I go through this demo, but if I know that you're in Clifton, because I plotted your address on the map that's in Clifton, then I know things about Clifton, like the expected income, the average house price, racial demographics, crime, voting, stuff like that. I can then make inferences about you. And that's really good for all kinds of machine learning, like credit scoring, customer lifetime value, predicting fraud, just a way to get a lot more data on a person. So so I hope that makes sense. And in other words, the clinics will know on this top little table, they'll know the location of the clinic, like where did that clinic run. They'll know the things in yellow, so they'll know how many sort of like times they've run a clinic in that location, how many patients they've had sort of like per day and per patients and so on. And based on the clinic's address and coordinates, and then you can look up the sort of like spatial codes that would map to like the suburb, for instance, and then it's like big data. So, and then you can then look up for that suburb things about the suburb. So like in this case, 34% of people in that area live in a flat versus a house, and a whole lot of other variables. So this is just some selection. So like, what percent of people in that area are black, white, colored, Indian? What languages they speak? Expected income, age, how they stand, and then the distance from that person's address to the nearest hospital, Pick and Pay, Woolworths, ShopRite, bank, mall, etc. So there's a lot of spatial data out there. So as I said, race, language, a whole lot of demographic stuff, voting, like the most recent elections. There were some maps on TV, but that's also at a real granular level. So per voting little ward, which is like as granular as the suburb, where within the 8001 Cape Town postal code, there are 17 statutory census areas and about as many voting wards. And you know the voting distribution for that ward. And then you can combine all these things to understand like how does crime data relate to voting data, demographics, and so on. There are a whole lot of locations. We just scrape the store locations from big retailers' websites and a whole bunch of other places. So, demo time. Hold that.
Okay.
So, this is an example of like the kind of thing that we've been building. So, this kind of explains a lot of what we're doing on this clinics optimization thing, but I'm just going to talk through some of the spatial stuff generally. So, the red points are clinic locations, but I'll just like hide that for a second and look at the map. So, one thing I always like to look at is if you look at where there's a high density of people thinking off advance. So, like darker is more, very like strongly southwest. And if you change that to where there's high density of black African people, you can almost like see the broadcast curve. But we had this at a real granular level. So if you zoom into Cape Town here, there's like expected LSM, we've got like expected race, there's Langa surrounded by a whole lot of high density of black people surrounded by high density of colored people, and as you see, was for white people. And language, a whole bunch of other features. Now, we then overlay locations of clinics. So here, for example, there's a clinic in Hard Bay. Now, this shape that's highlighted is the suburb boundaries for Hard Bay. There's an expected income, expected race, but we have all those variables. And if we know that this clinic is inside Hard Bay, we can then make assumptions about the clinic. And so, I mean, just sort of like high level, if we say like where are the clinics with like predominantly black people in that area versus white people, where the clinics that have had like a certain number of times the clinics run, you can talk to these things dynamically and see how other variables are related. But the basic idea is that we can these SWHP clinics guys have run these clinics historically. So, let's say that's like, Zoona's Cape Town, but all over the map, they run these clinics in a whole bunch of places. So, let's say that's where they run it historically. And we know which of these have which number of patients. So, like, if they're trying to figure out where to place these clinics moving forward, you might just say, well, let's look at the clinics that had, like, a high number of patients per day. So you'll filter those out, you'll see those tend to cluster in, like, these regions. There's, like, in Upload, and, like, there's one in Bishop's Davis. So, you might say, okay, well, let's run them where they did well in the past. And then, of course, you're only going to be running clinics when you've run clinics in the past. Now, part of why this spatial stuff is quite interesting to us is, and this could be like any use case. So they have an app and you have users in some small portion of the map. You have like a small number of users, or e-commerce, or customers, but it's not very good coverage for the map because you've only got like 100,000 customers and the map's big. So what you can do is, like, if this is where the clinics were run and were successful, and things about this region. So if all you have is a clinic location that's plotted on a map, like you just look at a pretty picture. But if you know things about the map, you can do that kind of spatial lookup idea to get an idea of what the expected understand, race, language, and a whole bunch of other features are at those clinics that were successful. So maybe this region over here you never run any clinics, but that's similar to this region, therefore you should run clinics there. Or similarly, if you've got a whole lot of store locations, you can then do the spatial lookup and understand what the features of different stores are spatially. And then you can look at where the stores that have high revenue, and then you can understand what the relationship is between these spatial features and the metric you're trying to optimize for revenue, number of patients, that sort of thing. And then you can fit a model to predict what the revenue would be for other regions where you've never run clinics, which is a basic idea of clinics with this clinics project. So, being that we're doing nerdy math stuff, if you phrase this as an optimization problem, on the one hand, there's a bunch of constraints. On the one hand, you want to minimize the maximum distance from each patient to the nearest clinic. Now, you want to put the clinics where there's a high demand, but if that's all in the metros or in high population density places, then the distance from a person who's either Potchefstroom is going to be too great for them to go to the clinic, so they're not going to go. Uber doesn't want to just send all the cars to Cape Town Central where there's a lot of demand, because they don't want to just minimize the average waiting time, they want to minimize the maximum waiting time, because if the waiting time is greater than 10 minutes, I'm not going to call Uber. So we also want to maximize overall bookings, where if you have more clinics scheduled during in higher demand regions, then there's a higher probability that the person's going to book a date, because dates might not all work for them and so on. Subject spacing clinics only in the regions operated by SWHP, so there's some NGO turf war going on where they can only operate in certain regions. But we can target people who live in regions that aren't operated in, as long as we know that the clinic in the region are operated in. And so, how we've solved this so far is we have a whole lot of historical data, and we can fit a model that predicts or rather predicts what the number of patients in that region would be given the spatial features. Now, sure, we may not have perfect data, so we can't predict exactly how many patients will go to that region. That could just be a matter of us not having certain spatial features. So the presence for taxi rank, for instance, may have a big determining factor on whether there's a lot of clinics people going to clinics in that region. But you can also measure the extent to which a model captures reality. And so it's really a sort of supervised machine learning problem where you have data, we know what happened, you want to predict for regions where you don't know what happened. Now, right now, we're using some big complicated neural network, but we can't really understand what's going on in neural networks in a black box, so we also just fit a multivariate regression to then understand how these various features are affecting, just to get the meters on the model, to understand the sensitivity of the model to those underlying spatial features. A couple of gotchas, so it's been an iterative process getting this right, because you've got these very skeptical NGO people being I don't know, maybe we shouldn't put a clinic there or so on. And one thing is that you use medians versus just the absolute number of clinics, because there may have been some big marketing push, and in the absence of the marketing push, it's not going to be successful in a region. You have to look at travel distances, and they're currently just using crossflight distance, but you can also compute the drive time distance from point A to point B. And the other thing is different population density. So these shapes are different sizes, and so there's different population density per shape, because the shapes are different sizes, you need to normalize for that somehow. So we're not doing this in the front end, but like the way you would running the script to do the optimization does it, you need to like use a grid and then project down the shapes onto the grid. Again, because you need normalized population density. So let's start with why would you use hexagons in the grid? Because it's easy to just use squares in the grid. Why would you use hexagons? Any questions? Except Adam's. Adam's probably going to ask this question. Any ideas? So
This optimized the shape.
why? Why is it the best shape? It looks cool. It's like a honey thing. It's because if you use a square, the distance from the center of the square to the corners is greater than the distance from the center of the square to the side. Yeah, so this is the most circular shape, because like circles is going to be uniformly capturing the grid bit. Yeah, so that's me. Thanks. Any questions, email me, etc. Any questions?
Get it quick.
Yes.
How many clinics sort of plays based on your models?
3 weeks with like around 5 clinics a day on 6 days a week, so like 30 each time, like around 100. But the USSD app, we've had like over 10,000 people dial, and like close to 2,000 people book appointments through that app. Yeah. And 30 days. So. Well, one other thing we didn't show, but like on the suburbs, we can see the race and so on. Yeah, I was still kind of like building it, but basically, given the clinic locations, you assume some radius around the clinic in which people will go to that clinic. And so you can then, for each suburb, you can count how many clinics are within that radius. So like, if you're in Woodstock, there may be 3 clinics over the course of a 2-week period. And so the number of appointment options for a person in Woodstock is 3. It's just like reversing the way we do the area lookup. And then color this bright red if there's 0. Because then, when we're planning with the SWHP guys and suggesting regions to operate, we can see a glaring big red patch of the map where if you live there, you're not going to be within 20 k's of anything. But yeah, feature work. Yes.
Where does your data come from?
Many places. The stuff we showed here is predominantly stats SA data.
Stats SA.
Yeah. I mean, like voting may have an impact on when someone goes for circumcision, but this was like just, lots of deadlines to start a plan. So, yeah. But we have a lot of other stuff. But that specifically was stats SA. Yes?
What is the business model? Where do you get like that from the NGO, or people need to pay for diving, or?
For the clinics, it's funded by funders. So the clinics, they're not charging money to go for circumcision. They're not charging money for the SSD, that's reverse bill. So it's totally free for the end user. They get money because big funding guys like the Preliminary Case Funding get them with grants, and then that's based on targets. They need to like optimize their targets, and they're essentially buying leads in the same way as like you're an e-commerce company, you'll then run Google ads, will have like a cost per acquisition. Same thing. Yeah. Our business model is like we're building this thing, and then we help people with their spatial data. That was the best use.
It'd be interesting.
Yes, very. Yeah. But we don't want to like close all future projects by taking sides at this point. Maybe at some point. Cool, thanks.
Alex, thanks, mate. And we're then anonymized in this. You can see anonymized using this R and possible data sets. I'm going to talk a little bit about how you would handle that in a big data sense, but still using the small data. This is the data visualized. So each of these circles represents a person in the data set. And each of the lines between the circles represents a relationship. So the circles are called nodes in graph terminology, but you can think of them as individuals in this data set. And the lines are called edges in graph terminology. And really what they represent here is that person at the top there, or the person in the middle there, this guy here,
knows this guy over here. And the way the data were generated were that people would write down the people that they said that they knew in an envelope with their name, and they would give that to the researcher, and then they would generate this. This node over here has a degree of 5. That means that he has 5 edges attached to him, or her. I'll tell you what the color coding is in a second. And in degree of 4, so he has 4 people that know him. And he says that he knows 1, he has an R degree of 1. And a component on the left there, that's an isolated group of people that aren't connected to each other. The color coding here, red is actually female, and green is male. And then I've added their racial information. And I haven't actually included the grade information as well. Right, so there's this really interesting thing, which is that if I know Jacques, and Jacques knows Alex, I'm likely to know Alex. It's this thing called triadic closure. So friends of friends are generally friends, and LinkedIn used this really successfully to target people, to say who you might know. So here is a triad. Yeah, these people all know each other, and this guy knows this guy, so it's likely that they know each other as well. So that's a useful concept if you're trying to understand who might know each other, where products might be useful, who you might want to actually send a message to say this is something that you might want. And maybe Helge's example in the beginning with the Amazon, I think they use this a lot. The graph measures and techniques that you can talk about using Apache Spark, that I'll just talk you through these. So, how connected are your friends? This is something called clustering. If all of your friends are connected to each other, then an idea propagates quite quickly through a network. Does that make sense to everybody? So in this case over here, you have a clustering coefficient of 1/3, because this is the central node. So he has 3 friends, and there's a tie between one of them. So there's 1 out of the possible 3 connections. And then the second line is clustering coefficient of 2/3 and 3/3. So if you have a graph and you have a very high clustering coefficient, you can pretty much assume that an idea might spread quite quickly through that graph. If you've got subparts of the graph that have high clustering coefficients, ideas will spread quite quickly through that. So that's quite a powerful conceptualization of graph, might be useful. Homophagy, this is also very, very cool. Like, people that are alike generally know other people that are alike. Birds of a feather flock together. You can have a look here on the right. There's strong homophily here by gender. You see lots of red with red. You also, if you look at the titles here, you see that there's quite strong homophily by race as well. So these are all interesting concepts. And you can use these for lots of different uses. My fiance used it for trying to understand how drug treatment might be effectively rolled out in prisons in the UK, and you might use it for product placement, credit risk, savings, consumer behavior. PageRank, this was something maybe many of you are familiar with, but it gives you an idea of how influential a node in that graph might be. And it's generally kind of given out, and so you have an iteration and everybody gets given a PageRank, and then they give out their PageRank to the people that they're connected to, depending on how many edges they have. So a good way to think about this is the US government website will have a lot of incoming links. Lots of people will link to that website. So it will get given a lot of PageRank, but it might not link to many other websites, so it won't give off a lot of PageRank. So this propagate, you kind of iterate through the graph and update this. And here's an example here, where you can see this chap over here, who's not very well connected, has a quite low PageRank of 0.15, whereas that chap in the middle who has lots of incoming connections ends up with a PageRank of 1.35. So this gives you an idea of who the influential people might be in a network, depending on how that network itself is constructed. Right. Label propagation. So you can also go through this graph and you can try and work out where the neighborhoods are. This was some graph that I just mentioned that you can actually get an idea that of the kind of different components and groups inside that. Maybe those people are very alike, maybe they know each other. That could be useful from a business perspective. Handling large social networks. This was how we handled this at Jumo, where we use GSM transactional data. We start from a CSV file on S3, we get these pumped in every day, and we produce that data on the Spark Amazon MIIA cluster. We get about 27 million nodes and about 300 million edges in a month. It's a very big graph. So this might be the way that you handle it. But what you want at the end is some way for people to interact with that data. So that's where the graph database comes in as quite a useful option. And that actually allows a fairly technically non-proficient person to interact with the data. I'll demonstrate the J interactivity now. So we can actually query this database and look for relationships that might be useful. So it has this cipher, which is like a SQL-like syntax. So you create, you say, I'm looking for person 1 who knows person 2. That you see this line over here. I'm reading from here. So I'm looking for a pattern where person 1 knows person 2, person 1 knows person 3, and person 3 knows person 2. And I'll return those P1, P2, P3, and that's what I get out of my much smaller graph. So that's useful in many cases. Here we're looking for one guy who's nominated by 3 women. So person 1 is known by person 2 who's a woman. Person 1 is a man. Person 2 is known by another woman, etc. And you get that return. And then similarly here, one woman is nominated as a friend by 3 men. So it's funny that there are more of this than there were of the first one. Yeah, so I think this is quite powerful. And I think it's quite good for conveying these concepts and trying to communicate the power of these graphs to people that might not be that well informed. I think that's actually the end of the talk, really. This is a GitHub link, which anybody might want to go and have a look at, where I've got the data. I've also got a Zeppelin notebook. So Zeppelin is a kind of notebook front-end for Spark, which is quite useful. And you can kind of have a look at that and see how these data were then constructed, how they were output, and then I think I put in the mark on the README markup how I imported it to Neo4j as well. And yeah, this was the notebook, but that I think we're going to scrap that today.
Yeah, so it's. Okay, thanks, Charles. That was fantastic. Any questions for Charles?
Yeah, great talk. Just curious, how do you deal with the time-varying nature of your graphs?
Yeah, so that's an interesting one. So generally, what you could do is create a node which is representing a time and link that to the nodes that are attached to that time. And then when you were querying it, you would query for people that were attached to that node. And you
resample it to regular time and you just keep it as a discrete.
Yeah, so we resample it at 1 month intervals. This is the Jumo data, which I haven't really spoken about too much.
And the direction of the arrows? So like, is it implied that it's bi-directional, or?
So in that case there, they were unidirectional. So, and that was because the data themselves were inherently unidirectional. Somebody nominated a record.
Yeah.
But they don't have to be that way. So Facebook, for example, that data won't be directional. But something like Twitter would. And I mean, PageRank itself really relies on some sort of directionality of incoming directly.
I was just wondering, like, how, if you have a bi-directional relationship, how that impacts on PageRank, because you don't know which way it's really going.
Yeah, so you could just split it both ways and just go both ways.
Well, it might be more powerful for the person who's got more connections.
generally, people that have higher incoming connections are more influential. They're typically the people that you would want to target in a graph. So for example, if you were a call center and you made lots of calls and you'd have a very high degree, but you wouldn't be very influential, for example.
The question on the text.
Yeah.
He's what is Spark doing all the work? Is the J doing all the work? Why do you need power?
So I don't know how familiar everybody is here with Spark and Neo4j. Spark is a parallelized distributed computing platform, and you can put all of the social network handling in there. What you can also do is to integrate that with Neo4j, to have Spark as the back end for Neo4j. In this case, I thought it was useful for this particular crowd to see the Neo4j front end. I'm answering your question. A lot of this you can, all the PageRank calculations, the clustering and all of that is calculated in Spark, so you can query and say, oh, I want to find a peak, and you can look for patterns in there as well. But you're just going to get text back in this table. It doesn't have quite nice cipher type.
Last question, because we've got 10 minutes for drinking snacks, because they want us out.
It's a good one. So, like a graph seems quite hard to distribute. I know you can shard chunks of a rainfall database, but can you speak about the performance on the Spark cluster, like how many nodes, what your query time, the size of the data?
Yeah. So it depends on what you're trying to do. Like just a standard query is almost instant across the 8 million nodes. But if you're trying to calculate PageRank, for example, now you're trying to move information between the node that might be sitting on this particular instance across to something else. And typically what that'll then do is it'll move that node there so that it can optimize the calculation on the new node. So it becomes problematic when you have individual nodes that have very, very, very high degree. So if you have one node that has, say, 30,000 connections and it's connected to another node with 30,000, that everything blows up there. So you have to apply some kind of filtering right at the beginning to try and really take out or at least reduce the degree of some of the nodes that you think might not be that interesting anyway. They're like some kind of ecosystem understanding, I think.
Can you run this whole thing on one machine? Is there
The Jumo data.
Well,
this was not 8 million. This was only 1,500 nodes. So this was very easy on one machine. If you wanted to run 8 million nodes, it would depend on how many edges there were. Like, typically, if you think of the kind of distribution of edges in a normal social network, it will be a power distribution. So you'll have a few nodes with very, very high degree. Most of them will have one or two. So, I mean, it's always a trade-off with these things. Depends. Good stuff.
Thanks. We are done.
Thanks for taking photos.